Kitchen chemistry. Now this is balloon and skewer. We talked about the scientific method, and we talked about how it happens naturally. This is a way of demonstrating how science happens all the time, every day, and people use it all the time without even realizing it. And all science means is knowledge. So of course we're always gaining knowledge, and science just does it deliberately. We want to know this stuff, we want to figure out what's causing this, or how we can use that. So here, you get a balloon, and you get a skewer. And you say, okay, well here, I have a skewer. Now, this is for you to know. You don't bring the skewer out yet. You just say, here I have a very expensive piece of scientific equipment. It's called the air indicator. Now the students will argue, the campers will argue with you, saying, it is not an air indicator, it is a balloon. And you say, wow, I paid too much for a balloon. But here, I'm going to prove that air takes up space. Did you see it? The more air I put in, the more space it takes up. Notice the size of the balloon here. It's very important not to go much bigger because you don't want it to be bigger than the skewer. So, back to the show. So you can see, this is how much air has taken up in my balloon. If air did not take up space, the balloon would not get bigger. So now I tie this off, like this. Now, I'm going to take this, and you pause. This is where the campers start freaking out. They start hiding their ears and going, ah! Because they're already making a hypothesis. They made the observation that you have a pointy stick and a balloon, and they didn't say anything. Then they automatically ask the question in their head, what is he going to do with that? The hypothesis they came up with in a split second was, he's going to pop the balloon. So they cover their ears. And you say, wait a minute, why is everyone covering their ears? And they say, because you're going to pop the balloon. Did I pop the balloon? No. What you did was the scientific method. You observed, you asked questions, and you came up with a hypothesis. And you predicted that if I poke the balloon, then it's going to pop. That was your prediction. Let's do the experiment. If I take the balloon, hold it with the tied side toward me, pull it out like this, take the pointed side of the skewer, put it right inside here. It didn't pop. It's a balloon pop. Not a pop balloon. Okay, so here, if I take it like this, I go to the top, and I go to the top, kids start freaking out, they think it's going to pop again, and it did. That does happen. So you have to be prepared for failure. That's why you have a lot of balloons. So you're totally right. Your hypothesis was correct. The balloon popped. But why didn't it pop when I put it in the bottom? Does anybody know? The bottom of the balloon actually has thicker rubber here. The latex there's more of. So if I take this skewer and I stick it through here, it won't pop because it actually hugs around it. Now if I put it through the top, and this time I'll be a little more careful, going through the very top where there's a lot more latex, and I push it through. Now notice I don't touch the pointed end. I put my fingers on either side, and as I push it through, it shouldn't pop again, but it might. Make sure you don't get your finger. There you go. And now you have a balloon kebab. There it is. Now, what's the hypothesis? Why didn't it pop? Now the only reason why I spoke about it being thicker there is because I actually popped the first one. But you make them come up with a hypothesis on why it didn't pop. And then you say, well, what if I go through the side? It pops.